In this video, we will go through how to do the aggregations on the tensors, like the mean, the sum, and also how to do the minimum, how to get the minimum and maximum values. So let's go back to here, edit. I'm deleting all the values over here. Delete select cells. Let's reconnect this to the tensor. If you haven't watched my previous videos, I would recommend you to go through all the previous videos, which helps you to understand the basics of PyTorch tensors. Okay. Okay. So because I deleted everything, I'm importing the libraries. If in case if you would like to know like what is the version of this one, this is the version FYI. So I'm creating a tensor, torch.tensor. Okay, let's do this one. Let's create instead of writing, we can use arrange. Start is equal to 0 and is equal to let's take 100. Step is equal to 10. Print x. To be very honest, I never recommend anyone to name the variables like x y, because it always gives lots of confusions. You can give a meaningful name, so which will helps you to understand, like for example, like a tensor with 10 incremental value, something like that. So because it's the demo purpose, I'm just using this tensor. So we have this one. So let's see how many values are there. X dot shape. So there are 10 values. Okay, this is fine. Okay, I would like to go with the one. Okay, let's only have 9 for now. Okay, so we have 9 values over here. Okay, let's get the minimum values. Okay, so how we can get toss dot minimum of x, right? So basically, it's the minimum value is the one, and then let's get the maximum values. So toss dot maximum of x. So basically, this gives you the maximum value, 91. So let's do the average or the mean. So for example, like average like 1 plus 11 plus 21 plus also on until 91 by 9. So how we can calculate toss dot mean of x? Oops. So we have come across an error. So basically input, I mean the data type of this one. So if you look at the data type of x, right, print x dot data type, it is in 34. But whenever we are calculating the mean, the value should be in the float. So how to convert? So basically it's very easy to convert. X float is equal to, okay, so x is our tensor dot type toss dot float 32, right? So let's print this one and also print the data type. Okay, so now you can see, so we have our tensor, which has the float values, and also the data type is float 32. So now let's perform this one, the mean torch dot mean of x. Okay, sorry, it's x float because we just named it as x float. Here it is 46. So this is good. And let's see, I mean instead of this time, so we have x tensor, right? So instead of returning like the minimum and the maximum values, let's see, like let's return their index positions. For example, the 1, the index position is 0, 11 index position is 1, 21 is 2, right? Because the index starts with 0. So let's do this one. Return minimum value index position, right? So what I can do, x dot, okay, torch dot argument minimum of x. So basically the value is 0 because the minimum value is over here. Let's look at return max value index position. Okay, torch dot argument max of x. So basically this returns this position here, 9. So this is good. And let's have a look at some concepts like view. So view is nothing but whenever you create a view, it's basically the copies of original tensors at the same memory location. For example, um, you have for example x is equal to, let's see this one, x is equal to what we have, toss dot arrange 10 comma 100 comma 10, right? This is the x. So now I want to use the same variable here, but instead of I can create y is equal, let's see whether it will be able to create or not. So if I have y, so we have copied the x into the y, and whenever we change the y, the x will not change. For example, let's have a look at y of, so for example, I'm changing the first index to 1000. Okay, now I'm printing y. So you see, too many indices for tensor of dimension 1. Okay, 100. Mhm. Okay, y is the tensor, and if in case, okay, if we change the value of here, the y, okay, let me pause. Okay, let's see how this works. So I'm creating a variable z is equal to, so I'm creating a view of 1 comma 9 x dot view. So basically I'm taking all the elements of x. So z dot shape, right? So we have the same, okay, let's take this one, x is equal to this one, and then z. So that z also 10 20 30 40, and this shape is this one. Now if I'm changing the first index of this one to 100, let it be like 100, right? So now if I print z, so the z value from 10 it changed to, sorry, to 100. And if I look at the x value, the x value also changed to 100, but actually we only changed the z value. So the concept over here is that x and z both shares same memory location. So therefore whenever we change any value with, in z, the data reflects in x as well. This is all about the weave, right? So this is something that you always have to remember. Now let's look at the stacking. Okay, let's look at horizontal. Okay, so for example, x stacked is equal to toss dot stack. So let's pass this x comma x comma x. So dimension is equal to 0 because I want it to be horizontal. Print x stack. Nice. If we wanted this to be vertical, so x stacked vertical is equal to toss dot stack. So let's have x comma x, dimension is equal to 1. Print this one. There it go. So instead of horizontal, now this is like vertical. And if in case if you go with dimension 2, it will give an error. So let's see this one, toss dot stack x comma x, dimension is equal to 2. So basically dimension is equal to 0 means it's a horizontal, dimension is equal to 1 is a vertical, dimension 2 means like it will not understand. Okay, let's understand squeeze versus unsqueeze. These are very much important topics. Okay, so what is squeeze and unsqueeze? For example, let's look x is equal to, let's create tensor toss dot arrange 1 comma 10 1. So print x, we created a tensor here. Or we can do, we'll take a random tensor toss dot rand 3 by 4 tensor, x is equal to this one. Now, so we have like two arrays here, right? So if you want to delete one, let's squeeze this one. So unsqueeze. Okay, let's squeeze this one. Squeezed is equal to x dot squeeze. Now let's print squeezed. Interesting. X is equal to x tensor x dot squeeze. Why the squeeze is not happening here? Okay, let's go back. Let's see how this squeeze works. For example, if you have a tensor, toss dot tensor of values. So, for example, like two-dimensional values 1, 2, 3, 4, 6, 7, 8, 9, right? So, if I print this one, you can see that we have two dimensions here. So, if in case if you want to reduce one of the dimensions, I mean x dot ending, if you would like to reduce one of the dimensions here, so what we can do, squeezed is equal to x dot squeeze on this one and print squeezed. You can see one of the dimensions is reduced, and also if you look at the dimensions, and also if you look at the dimensions, okay, it is one. Right? If in case if you would like to have if you would like to add one more dimensions to this one, it's very easy. So squeezed is our tensor dot unsqueeze. Okay, so dimension is equal to 0. This is very much important. If you can have this one, it will add the two arrays here. If in case let's see what will happen if we put dimension is equal to 1, it will add something like this one. And next one, so we will have a look at indexing the tensors. Indexing tensors. Okay, so x is equal to torch dot arrange 1 comma 10. So basically you can write one here or one is optional. X is equal to x dot so for example let's print x. So this one, it is looking like this. So I would like to create a three-dimensional one. So basically what I'm going to do is that x is equal to x dot reshape 1 by 3 by 3. So print x. So you can see, so we created three dimensions over here. So x dot ending, oh my god, too many spelling mistakes. Okay, if in case if you would like to have the first of this one, so you can start with x of 0. So basically it gives like this whole one. If in case if you would like to have the first value, I'm typing, I'm going to x of 0 of 0 of 0. This gives the value 1. If in case if you wanna have something like the first value, can go with item 1. And also if in case if you wanna have something, the first value here, right, you can select x, this one 0. Let's see what it will return. So it has written 0 means this 1147. And if in case if you go with 1, so basically it will be like 258. And 2 means it will be 369. So if in case if it is like 0 here, let's see this one, what it will return. It will return the element 369. Okay. And then in the next video, I'm going to explain how to convert the data from tensors to NumPy and from I mean tensors to array and from array to tensors. Thank you. Keep watching all the videos and please do subscribe to my videos and do like. Thank you.